And it's time to start. So, good morning, class. It's Tuesday, and we're moving right along. I will get to start grading your papers today, so some of you guys might start seeing some grades start appearing on GradeLink. I will have them all done probably by tomorrow, but some might start appearing. If you get curious, you can take a look and see. So let's dive on in today. We are on page 392 today. I'll let go of my coffee. So we're going to be doing pretty much what we did yesterday, except that yesterday you were given the triangle and it was all set up for you. Today, part of your task is to take the information that is given to you, and you have to properly set up a triangle and then do what we did yesterday. So you're going to have to remember some of the things that we learned at the very beginning of this chapter as far as setting up triangles and naming sides according to the angles and all of that. So we'll go through this example together, and then hopefully we have some time. Maybe we can even do a couple of problems together. That'd be awesome. So on example 8.2D, your instructions say, find each of the three basic trig functions for angle A, okay, that's important, using the given information. So this is an example of all of the information that is going to be given to you. So you're going to be, okay, this is example 8.2D. Okay, so basically your instructions will be something similar to this. Find trig functions for angle A, and you will be given information like this. C equals 9 and A equals 5, and you've also been told angle C is the right angle, which is always going to be the case in these problems. So, in order to do what we did yesterday, we first have to get this triangle set up, okay? So, let's set up, this is backwards from what I usually do, but I'll do it the way that your book has it shown. Okay, so we're going to set up a right triangle. I know that angle C is the right angle, so I know that this vertex down here is C. And then I can go ahead and name the side opposite it, which is the hypotenuse. That's this guy. This is my little c. So remember, your angles have to be named by a capital letter. Your sides have to be named by lowercase letters, just like when you use the Pythagorean theorem. Those are all lowercase letters, okay? It is important whether you use lowercase or capital. So now at this point, let's see what information that we've been given that we can plug into this. So C equals 9, so that's this guy right here. So that's going to be the hypotenuse, okay? So he properly goes right here. And I know that A equals 5. Now, it doesn't matter if I call this A and this B, or this A and this B. So we'll just stick to the script here and do it like what's shown in your book. And so they chose for A to be over here, and I know that this is 5. All right, so that leaves this side over here being B. All right, so now let's finish. We've got all the sides properly named. Now let's go back and finish naming the angles or the vertices, same thing, because I'm having to find sine, cosine, and tangent of angle A, but I can't do that until I know which angle A is. So, so this is side C, and he's opposite his angle, right? Y'all remember that? So this is side B. So he has to be opposite his angle, so this has to be B. And this is side A, which we know has to be opposite its angle, so that's A. So that means this is going to be our reference angle once we get down to the point of finding sine, cosine, and tangent. All right? So, but the first thing that we need to do is, just like we did yesterday, we need to fill in all of these side measurements. So we're going to use the Pythagorean theorem to find this missing side. So we're going to start with the Pythagorean. And then we'll plug in the ones that we know. I know that A is 5, so that goes there, 5 squared, plus B squared, because I don't know what he is, so he just stays a B. And C is 9, so I'm going to substitute 9 in here. Okay, so now we just start doing the math. So 5 squared is 25, plus B squared, 9 squared is 81. This guy stays put on the left side. I take that 25, I move it over, and when I do, his sign changes. And I think I brought a calculator, but it's in the book, so I'll just follow here. Okay, so this is 56, but I need to know what B is, so we're going to square root it. So this simplifies down to 2 square root of 14. So this, I'm thinking, is 2 times the square root of 14. So we're going to take a second and we're going to check it, because when I'm plugging in numbers for opposite, adjacent, and hypotenuse, I want to make sure that they're the right numbers. So let's just check this and make sure that this is true. So checking this. A is 5 plus B, I'm thinking, is 2 square root of 14 squared, and then C is 9. So this is 25. Okay, so this is, remember like yesterday, you have to put all this whole term right here in parentheses so that your calculator knows that you're squaring the whole thing and not just the radicand. So that's 2 square root of 14, close your parentheses. Oh, I don't know what I just did. And then square it. That should tell you that it's 56. That's an 81. I take that 56 and I add 25. It is 81. 81 does indeed equal 81. So, okay. So what that tells me is that I know that these numbers agree. They work, all right? So now we can find our trig functions for angle A, which is down here. So we're going to do the sine of A, the cosine of A, and the tangent of A. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Hopefully, if you don't have them memorized, you're getting close. So here's our angle that we're doing, because our instructions told us to find the trig functions for angle A. So opposite is 5. So plug 5 in there. Hypotenuse is 9. That will not simplify. It's as simple as it gets. And the cosine is adjacent. So that's this, 2 square root of 14 over hypotenuse, which is 9. That won't if these would simplify, you would simplify those, okay? You cannot do anything with these numbers, right? I mean, you know that this guy is really just a decimal. That square root of 14 is just representing a decimal. The only numbers that you can simplify are whole numbers, okay? So if these would reduce, you would reduce them, but they don't. And then opposite over adjacent. So opposite is 5. And adjacent is 2 square root of 14. And you have to rationalize your denominator, right? Because we are not allowed to keep a radical in the denominator. So you just punch in the fraction, 5 over 2 square root of 14. Get your cursor out of your fraction, hit equals. All right, so this will rationalize the denominator for you. And that's as simple as it gets. So, before we move on, are there any questions? We have time, we can do a problem or two together. Probably the hardest part of this is just ensuring that you get your triangle set up correctly. All right, well, if everybody's good, let's tackle a couple problems. So I'll go ahead and do this. Your assignment is going to be 8.2D. We're going to do numbers 19 through 24 on page 395. So just to fill up a little more of our class time, let's look at number 19. So first let's read the instructions for this section. It says find the values of the 3 basic trigonometric functions of the indicated angle using the given information. And remember, angle C is always the right angle, okay? So that's given to you in your directions. So that applies for all of these problems. So number 19 says, find the trig functions for angle A. So we're finding for angle A. That's going to be our reference angle. And you have been given the fact that A equals 12 and B equals 5. So I have to see this. I have to see you draw your right triangle. I always make mine go this way. So you can draw it however you want. This just seems logical to me. Again, I want to see your triangle. I want to see your triangle drawn, and I want to see it properly named, all of your angles and all of your sides. So I know that this is C, that's fixed, okay? That's a fixed angle. The right angle is always C. So I can go ahead and name my hypotenuse with a little c. And I know A and B. So it doesn't matter if I put A here and B here, or A here and B here. So I'm going to do A right here. A equals 12, and B equals 5. So I determined the sides where A and B go. So, but I have to properly name the angle, okay? So if this side is side A, then the angle opposite has to be angle A. And if I named this B, then this one up here has to be B, okay? Now if you switch them it's fine. We're still going to end up in the same place, okay? So now we have to use the Pythagorean theorem. For those of you who had geometry, you can probably tell me right off the bat what the hypotenuse is, because 5, 12, and 13 go together in the Pythagorean theorem, okay? Those are very common combination. 3, 4, and 5, and 5, 12, and 13 are very commonly used combinations for the Pythagorean theorem. But we'll go through the steps because, you know, about half of you, I guess, haven't been through geometry. So to find this missing side here, we start with the Pythagorean theorem. We substitute 12 in for A, so that's 12 squared, plus 5 goes in for B. 5 squared equals C squared. 12 squared is 144. 5 squared is 25. And this is 169. And I square root both sides. C equals 13. All right, so I'm going to take a second and I'm going to check it just to make sure that it is correct. Nothing worse than sticking wrong answers into formulas to use. So A is 12, B is 5, and C is 13. Okay, if you punch that into your calculator, it's going to tell you that it's 169. Okay, so I know it's right. I mean, most of us know, like 5, 12, and 13 just go together always in the Pythagorean theorem. Okay, so all of our sides are named, and we have our angles properly named. And so now you just have to ask yourself the question, which one is my reference angle? I got to find sine, cosine, and tangent, but of what? Okay, so that's where you go back to your directions if you don't remember. And we're finding the trig functions for angle A. So it's this one right here. This is our reference angle. All right, so we're doing the sine of A, the cosine of A, and the tangent of A. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So called TOA. All right? So this is our reference angle. So opposite is over here. That's 12. Hypotenuse is the longest, always the longest side of a right triangle. Opposite there, that right angle. So the cosine of A, this is adjacent, so I plug in a 5 there, and hypotenuse is 13. And the tangent of A is opposite over adjacent, so that'd be 12 over 5. And those are your answers, but I still want to see all of it, okay? Especially this also. So how's everybody feeling about that? Everybody's sitting pretty. Everybody good? All right, well, we have a little bit more time. If I had you in class, we'd probably do one more together, so let's do one more together. Take your silence as a good thing, I hope. No sense of writing that again. Okay, we'll do one more, and then I'll let you go. So let's do number 20. So the instructions for 20 say find for B angle B, and we know that C is 25 and B is 7. So I need to see your right triangle drawn. There's your right angle. I know that he is C, and I've been given C, so I can plug that in there. And I know that B is 7. I'm going to call this leg B. Doesn't matter. But if I call this leg B, then that means that this has to be angle B. And if I call this side A, that this has to be A. Okay? All right, so let's use the Pythagorean theorem to find this missing side right here. So I don't know A, so that just stays in A. I plug 7 in for B. Stays in the right of B. And 25 goes in for C. 7 squared is 49. 25 squared, I believe, is 625. Let's see here. So I take that positive 49, I move him over, he becomes negative. Gives me 576. But I don't need to know what A squared is, I need to know what A is, so I square root. So on your calculator, you can just hit square root your answer. That's 24. So let's check these. Let's make sure that all of these numbers work in our formula. So I want to substitute 24 in here, 7 in here, and 25 here. So 24 squared is 576, plus 7 squared is 49, 25 squared is 625. So 576 plus 49 is indeed, so that's true. Okay, so now we can actually solve for our final answer. So we're looking for sine, cosine, and tangent for angle B this time. So I need to see the sine of B, the cosine of B, and the tangent of B. And your formulas for these trig functions: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, oh, that's ugly. Now all we have to do is plug these numbers in. So we got to come up here and find our reference angle. In this problem, we're finding it for angle B, so that's right here. Okay. So now we're looking for opposite, adjacent, and hypotenuse in relation to angle B. So the sine of B is opposite, so I come opposite of B, that's 7. Hypotenuse is 25. The cosine of B is adjacent, so that's the side next to it, but not the hypotenuse. Next to it, which is 24. Hypotenuse is still 25. And then the tangent of B is opposite over adjacent, so that'd be 7 over 24. So those are all of your answers. Right? So I will leave the rest for you to do if you don't have any questions, then we'll just call it a morning. I'll give you guys just a second to speak up if you need anything. If you're still awake, you might have gone back to sleep. I don't know. All right, well, hey, no news is good news. So you guys have at it. Have fun with the rest. And I'll meet you here tomorrow, and we'll keep working on trig functions. You can start looking for your grades here pretty soon.